So we know that the hydraulic pumps and all daily life we are using it, and we know the application of that, what the hydraulic pumps do and all. Okay, we have a definition. We can go to a definition like this: the mechanical device that uses to convert mechanical power into hydraulic energy is known as hydraulic pump. So usually we, when come to the turbines, means there the energy from the hydraulic, that is the potential energy, is converted into mechanical energy. But in hydraulic pumps, we are providing energy, mechanical energy will be used to convert into hydraulic energy. So that means it will be in the form of pressure and velocity. And next, before going to the explanation here in the hydraulic pumps, the coming to the topic, what and all we discussed today, we'll discuss the classification of hydraulic pumps, how these hydraulic pumps will be used, and working principle and applications, and next we will discuss the classifications and all. First we will discuss, and then we'll go to working of mainly two type of pumps: centrifugal pumps and reciprocating pumps. And then we will discuss the cavitation and priming. So this cavitation and priming is the concept comes over there. What is cavitation, and we'll discuss one by one later. And first we'll go to the classifications. So pump can be classified mainly two main categories. The first one is dynamic pressure pumps, or this can be called as non-positive displacement pumps and the positive displacement pump. What is this dynamic or non-positive displacement pumps? Generally, we say in this kind of pumps, the kinetic energy is added to the water to get the or to increase the velocity of the water. So that is what will be done in the dynamic pressure pump or the non-positive displacement pump. What is that? The kinetic energy is added to the liquid, and then we will get the velocity and pressure. So that is what will be done in dynamic pressure or non-positive. In come to the positive displacement pumps here, so we will be adding the pressure to the liquid by trapping the fixed amount of liquid or fixed amount of fixed quantity of liquid in a cavity, and then we will increase the pressure of the liquid. So like this, the energy will be transferred in positive displacement pumps. Got it? Here we will add the kinetic energy to get the velocity, and here what we do, we will trap some amount of specified amount of volume of liquid, and we will increase the pressure, and then we will get the output. Like this, the difference between the dynamic or non-positive and positive displacement pumps. We'll come to first the dynamic or non-positive displacement. First one is centrifugal pumps. So this entire working and all will go centrifugal pumps. How the centrifugal pumps look like? This is what the centrifugal pumps. And here water will be entered, and the impeller will be rotated with the high speed, and then water will be displaced in a casing with a high velocity, and later it will be discharged. Like this centrifugal. This mainly is because of centrifugal action, the water will be displacement take place, and the energy, the mechanical energy is converted to liquid in the form of centrifugal force. That is why it is called as centrifugal pump. And next one is propeller. So propeller is something like this. The shaft, there will be big blades will be there. So the mechanical energy is transferred to these blades, and these propeller blades, like we discussed in a Kaplan turbine. So like this, the blades will be there. When the blades rotate, water will be displacement take place, and it will be lifted. Like this, water will enter and it will be displaced. This is what the propeller type of pumps will be done. And turbines. This one already we discussed in the previous chapter. Turbines, reverse of turbine. If you supply water to the turbine, the power will be generated, and then if you give power to the turbine, water will be lifted. Best is Francis turbines are used in that cases. So Francis turbine, if you supply water to that, what happens? The power will be generated. If you give power to that Francis turbine, then it will lift the water. So that is what turbine type of the pump solver. Next, coming to the second kind of classification, the positive displacement. Here in the positive displacement, we have two types. One is reciprocating and rotary. Reciprocating means we know that the movement, front and back movement, because of the front and back movement, the to and fro motion, the water will be displaced. So that is why it is called as reciprocating. And rotary. Here the continuous rotation motion will take place. Because of that, the water will be displacement take place. So we will go one by one for reciprocating. First one is piston. by using piston, how the water will be displaced. And this is how the piston arrangement. Here see reciprocating. The piston will be moved front and back while taking back the vacuum creates, then the valve is open, water will enter, and then pushing this inlet valve will close and outlet valve opens and water will be discharged like this. A continuous front and to and from motions, the water will be sucked and it will be delivered. This is how the reciprocating motion takes place, and here the piston, by using piston arrangement, water will be pumped or water will be discharged. And next, the diaphragm. How this diaphragm will be works. So we go here. We have a two set of diaphragms. There will be one set also they can use it. So this diaphragm, what it will go, when the diaphragm pushes, there will be ball arrangements will be there. These are the balls, one side balls. When the water is taking inlet, this will open, water will enter this gap. When the diaphragm is coming back, there is a gap creates. And then when the diaphragm is pushing front, and then water will be the high pressure, this wall, the inlet valve, this will be closed and outlet will be open and water will be discharged like take place. Like this, if they are having two sets, then one side if it is inlet, this is this suction stroke means this will be delivery stroke, and this will delivery stroke means this is suction. Like this alternative that take place, and then water will be discharges like this. So this is how the diaphragm pumps will be works. And next, coming to the next category, this rotary. In this rotary type of pumps, we have a gear pumps, lobo, screw pumps, vane, and rotary plunger. So we'll go one by one. The gear pump. These are gear pumps. Here, what happens? The casing will be there. The gears will be situated like this. We know that the gear teeth, there will be a gap in the gear teeth. So here the main picture comes over there. So here we will maintain the gears like this. Water will be, this red color is the inlet and the blue is outlet. So while rotating, there is a small space between the gears. That cavity will be filled with water and that will be moved along with the gears and it will come to the exit port. Like this, the continuous water will be trapped in the between the gears and it will be delivered. Like this, continuous motion take place and either side and water will be discharged. Like this, the gear pumps will be works. And next one is lobo. Lobo means something like that, means there the heat will not be there. So here the structure is like this. So it will create the gap over there. You can see the blue is the inlet and red is the discharge. And see what happens here. Water will be take place and the cavity is made it by because of this structure, and water will be pushed over to the outlet. Then water will be discharged take place. Like this either set, two sets we have, three sets also, that depend upon the number of arrangements it can be made. One set also they can have. So like what happens when the water is enters and it will be take over this cavity and it will be pressure increases its pressure. Water is trapped in this gap and water will be exit. It will take place over here. So like this, continuous discharge will be take place. And next one is screw type. So we know screw how it will be. Screw or will be like this screw set they will use it, or one screw set also they can use it. The gap in the screw, that the whatever the gap is, that water will be trapped there while moving. All the water will be trapped and it will keep on moving this gap in between these two the teeth. There is a gap will be there. Through that gap, water will be delivered to the outlet. Like this, continuous water flow takes place. So like this, the screw type of the pumps will be works. And next one is vane. So the vane type of pumps will be like this. There is a shaft at the center. To that, number of these veins are attached. These veins are having flexibility, or the cavity is made that the veins can be moved inside and outside. When it start rotating, so because of the vein will be attached to the casing, and that will be creates a gap between that. The water is trapped in that. It will be taken out and it will be delivered to the outlet. And then one side of the casing will be having the enough space to trap the water, and other side it will be close to the shaft. So here there is no gap. Then the provision is given in the this veins, so it will be moving inside and outside. So here when coming to the gap space, the water will be trapped and it will be moved and it will delivered. When it comes to the closing case, the vein will be, this structure will be go inside, and like this continuous movement will take place and water will be discharged. This is about the vane pump. And next one is The rotary plunger, this is the last classification. Subway out how it will be working. The plunger will be arranged like this, and the water will be pushed, and when it is going back, the vacuum is created through the inlet. The water will be filled in the cylinder, and then again the plunger will pushes the water, and while coming back again the vacuum created, then the water will be take place to the cylinder, and it will pushes like this pushing direction. It will take place by using of this plunger. So how this the plunger type of the pumps will go. So the classification of pumps. Okay, now we will go one by one. So coming to the working of centrifugal pumps. The first, this is the centrifugal pump. We'll explain here how the centrifugal pumps will be works, the construction and different parts, and also the working principle of this. Coming to the construction part, what are the different parts of the centrifugal pump? Okay, just observe here, one by one we go. First one is impeller. The impeller is the main art of the centrifugal pump, and then eye of impeller. This is the gap is not, this is the eye of impeller. This is also known as the inlet of the pump. And next one is casing, and next one is this footwall with the strainer, and this is the sump and suction pipe, and sump, and this is the suction pipe, and next is vacuum gauge and delivery pipe, and delivery the pressure gauge, and then this is the delivery. This is how the construction parts of that different main parts of the centrifugal pump. Then we will go one by one here. What are the main parts and what is the application of that? The first part is basic. This is the footwall and strainer with the suction pipe. So this is the suction pipe. The suction pipe is nothing but this is the pipe connecting between the rotary. That is impeller will be there. No, from the impeller to the sump. This is the sump will be there. That is the suction pipe. The suction pipe is connect the connection pipe between the pump. That is the impeller to the sump. And before that, before the sump, whatever end of the one end of the suction pipe will be having footwall and strainer, and other end is connected to impeller high. That is inlet of the impeller or impeller high. What we said, no, that is what it is connected. Suction pipe connects the impeller high to the footwall. So what is this footwall and strainer does? This strainer, first we'll go with the strainer. The strainer is something like a mesh type of material will be used there that will avoid the entry of the whatever the impurities or dirt or any other the waste material like that. There will be pieces of any cloth, anything. Means that is a dirt. It will mainly function is it will not avoid, it will not allow to go any kind of dirt material or unwanted material to pump. That is the strainer function. And then footwall. This footwall will do, it is a one side wall, so it will allow water to enter to the suction pipe, but it will not allow the water to go back to down. So this is what the footwall will do. And next, coming to the next part, the same main part of this. So this is the shaft, and this is what I said, eye of the impeller or inlet of the impeller. So here the suction pipe is connected, and on around of this eye of the impeller, there is number of veins. These veins are back curved veins, and it will be having the increase in cross section area. So this is the construction of the impeller. So when the this main function of the what I will just go one more video here. You can just check it how the impeller is there. So this is what the impeller will be structured. The inside there will be veins will be there. These are the veins will be back curved, and see you can in cross section area is keep on increases. Why it is made it? So we'll go here. So when the impeller start rotating, so water will be taken place over here. The high of the impeller, water will be taken here because of the high rotational speed. The water will be moving outside because of centrifugal force. When it is rotating, what happens? Because of this back curve vein structure, water will be made moving outside of the impeller. So that will increase the pressure and kinetic energy because due to mainly centrifugal action. So that's why water will enter through the high, and because of high rotation, and it will be increases the pressure and kinetic energy, and it will be moving outside. When it is moving outside, what happens? At the impeller high suction, the vacuum creates, and when the vacuum creates, the negative pressure creates, the water will take place from the sump to the thing. Again, it will be continuous rotation take place. And next, if the priming, if there is no water present between the impeller eye to the sump, If there is an empty space, then what happens? There is no such negative energy created. The water will not move. That next we will discuss how the priming should be done. Got it? No, that is the working of that. When the water is entered to the impeller eye, when the impeller rotates with the eye speed, the water will come to the outside of the casing. This is the casing, and because of that, water will be getting out with the increased pressure and kinetic energy, and the casing will be take that water to outside. This is the casing structure. See, this casing structure is increasing area. You can just see the area is keep on increases. Why it is made means to reduce the at the exit of the impeller kinetic energy is high, so we want to decrease the kinetic energy and increase the pressure. So that's why if because of this wall structure, the pressure velocity decreases and pressure is increases. That's why the cross-sectional area is increased. And next is delivery pipe. This is the delivery pipe that is connected exit of the this casing, and there will be wall delivery wall will be connected. Because of this delivery wall, we can control the outlet flow. So this is what the construction of the main that is centrifugal pumps. Like this, it will be work. And you can see just this one, my full arrangements. There will be for the casing, there will be a stuffing box will be connected and suitable like gland is connected over here, and then this is a supporting structure is made here, and then bearings. Mainly to shaft, there will be a two set of bearings will be added. The function of bearings, we know that it will give the rigid support to the shaft and smooth function of the shaft will be done. This is the bearings they will going to attach to this one, and then two bearing set will be attached, and then there will be gearbox will be attached to this, and this is a complete structure of centrifugal pump. Point. These are the whatever the functions we discussed. No, the same things over here. So by part explanations are given here. The section pipe, what is section pipe and what is the function of that, and from where to where it is connected, all be given. This is the section pipe information. And next is the impeller. So what is the impeller and what the impellers do? All these points are there. Then casing, the casing functions and its applications also given here. And next, the delivery pipe. And last one is the working. So this is whatever we discussed now. So that working principles are given in the points. You can go through this and you can note down later. This is how all about the centrifugal pump. And next one is reciprocating pump. So the difference between centrifugal pump and reciprocating is they completely because of high rotation, the centrifugal force will be take place. Because of centrifugal force, the water displacement takes place. But in reciprocating, because of the front and fro motion, to and fro motion, the water will be trapped and the water will pressure is increases, and then water will be delivered. So that's why this is the reciprocating, completely different between centrifugal and reciprocating. First, we will discuss the parts. So what are the main parts in the reciprocating pumps? The first sump will be there. The main application of pumps, we know that from the sump to the delivery edge. So this is what the process takes place. And between that, the first one suction pipe is the main that will be connected from the sump to the main cylinder and through a suction wall. Suction wall will be, this is the function of the suction wall we'll discuss later. And this is the suction wall. Next, the cylinder is connected. And inside the cylinder, we have a piston and the piston rod is there. The piston rod will connect the piston to this connecting rod. And then connecting rod is connected to crank. Connecting rod is connected to crank, and crank is connected to shaft. And this crank is rotate around the 360 degree, means because the whatever the prime motor we are giving, that will be rotational motion. We have a motors that will convert the mechanical energy into that current energy, electric energy into mechanical energy, that is rotation motion. This crank will rotate in a 360 degree, and then because of this connecting rod, it will converts the rotation motion into this front end, that is a reciprocating motion. And next, delivery pipe. Before delivery pipe, there is a delivery valve will be there. So through this, that the water will take place and it will be supplied to delivery tank. So this is what the constructional parts of the reciprocating pump. Then we'll come to what is the working one by one. What is section for purpose of section pipe and section wall, piston, plunge and all, one by one we'll discuss. Now suction pipe, same thing. Suction pipe, what it will do, it will connect from the sump to cylinder connection. It is a connection pipe from sump to cylinder. And suction valve. The function of suction valves, these valves are one-sided valve, one-side valve. So what happens? Suction valve will open during suction stroke. Only one stroke it will be open, and other delivery stroke, this will close. Okay, that is what suction valve function. It will open during suction stroke and it will close during delivery stroke. And this is the piston with the connecting rod. This piston will be is free to move inside the cylinder from front end to back end. This piston will be moved from front end to back end. It will move. When it is moving from front end to back end, so that is known as suction stroke. When the same piston moves from back end to front end, it is pushes. That is called as delivery stroke. Got it? Suction stroke is from the front end to back end, the piston will be moved. That is suction stroke. And from the back to front, it will move. That is the delivery stroke. That is the function of this piston will do. Then piston rod will connect between the connecting rod. Here I said, connecting rod, this converts the rotational motion into reciprocating motion. That will be done by this connecting rod. And the crankshaft, I said, is that the crank is connected to the shaft. It will rotate in the rotational motion. That is 360 degree, it will rotate. And next, delivery valve. So this delivery valve, I said these valves are one-sided valve. This delivery valve closes when the suction stroke. That is the inlet stroke or suction stroke. During the suction stroke, this delivery valve is closed. And during delivery stroke, this will be closed and this delivery valve will get open. Got it? This delivery valve opens only during delivery stroke. But during suction stroke, this will be closed. Okay, that is the function of this is the delivery valve. And next, delivery pipe. This will connect from the delivery valve to the delivery tank. Whatever delivery tank, this will be connected. Now, this is how the constructional parts and main application means the main importance of the different parts of that. Coming to the working. So what happens during the working? The crankshaft will rotate around the 360 degree, and while rotating it, the main two strokes will take place. First one is from 0 degree to 180 degree. From 0 degree to 180 degree, the suction stroke will take place and water will be enters. And from 180 degree to 360 degree, the delivery stroke will take place and water will be, this delivery valve will open and water will enters to the delivery tank. So this is how the working take place here. That is when the piston rotates over here, when the 0 degree to 90 degree. So while process of opening from 0 to 90 degree, so what happens? The suction valve opens. That means when it starts the 0 degree to 90 degree. So when the valve starts from 0 degree to 90 degree, the suction valve is opens and water will start entering to the cylinder. When it is moving 0 to 90 degree, it is started moving and here suction valve get opens and water will start entering. See, water will start entering and keep on accumulating in the cylinder because of the vacuum pressure. When it reaches 180 degree, that is complete finishing of suction stroke. This is off, and when the crank rotates to 180 degree, that will mean completion of suction stroke. 0 to 180 is completion of suction stroke. Then the piston will move to the end of it, dead end of the cylinder. So this is just process. See, when it reaches the 180 degree, the piston will completely reach the back end of the cylinder. Then the complete water will be filled. During that, the suction valve is get open. And when it starts from 180 to 270, that is a delivery stroke. When it starts, then suction valve is get closed. See, when it is starting, then delivery valve about to open and suction valve is get closed. And when it reaches to 360 degree, complete suction valve is get closed and delivery valve will completely open and the pressure is increased. See, when it is moved to 180 to 270 degree, the pressure is increased here. Pressure is increased and this is with the high pressure, the delivery valve about to open. This will be about to open and when it moves again, the suction valve complete close take place and delivery valve is opens and this water will be moved through the delivery pipe to delivery tank with the high pressure. So that is what then means the piston will be from back end to the front end, the piston movement will be take place. When the piston movement will take place from back end to front end, the delivery valve will get opened and suction valve is get closed and the water will be displacement to the delivery pipe to the delivery tank. So we'll see here what happens when it is moved to 270 to 0 degree back to initial position pressure. The delivery valve is open, thing water is running to the delivery pipe and it will reach the delivery tank. This is how the working of reciprocating pump. Understood? No? This is the construction and working of reciprocating pump. And these are the points The constructional points, these are some of the important, whatever the parts we discussed, section 5, what it means, and suction valve, cylinders, piston, plunger, and delivery valve, and crack and connecting rod. These are the different constructional parts, and we have a definition over there. And next, we will have the working working principles, that these are or whatever we discuss, all the points are here. If you have the definition, you can note down these points later. And this will finish the construction working of centrifugal pumps and reciprocating pumps. And last one is we have a one more concept, that is cavitation. What it cavitation means so during the operation at the eye of the impeller, phenomena will take place. So I already told you that when the pump is start rotating with the high velocity, water will be reaching the casing. The whatever the impeller high water present, because of the high rotation, water will be enters to the casing. When it is entering at the eye of the impeller, the negative pressure created. The negative pressure, the pressure is less than the atmospheric pressure is created, and because of the negative pressure, from the sump water will be take place over here. From the sump water will be rushed to the impeller, and then cycle continues. Water will be discharged. This is the normal process. During the some time, what happens? Uh, the pressure difference will take place. The pressure, whatever in the inlet of the high, that is less than the vapor pressure of water. That is the concept will be when the pressure of water is reduces less than its vapor pressure, there is a water will starting point. See, this is what the pressure is less than the vapor pressure of the water. There is a bubble formation take place. These all means water start boiling at the inlet of the high, that is the inlet. Water will start boiling and the bubbles will take place without adding the heat. Because of the pressure difference, water will start boiling and the bubbles will start take place. These bubbles or get expanded over the impellers. So these bubbles with the having high pressure, this is because of the net positive suction net. That is the net positive suction net is available is less than the actual. Because of that, what happens, these water bubbles will be take forms at the inlet of the impeller, and these bubbles are get exposed, or these bubbles are get expand at the impeller blades, and it will damage the blades, and also it will cause the vibration. All other negative effects will be take place. This is what cavitation means. Cavitation is means because of the pressure at the inlet is reduces less than the vapor pressure of the water. Due to that, the bubbling formation take place at the inlet of the impeller eye. So that bubbles moves along the blade, and it will collapse at the blade, and it will make damage to the impeller blade or casing, anything like this. This is what the cavitation occurs. So cavitation is not a good thing. This is a problem in the pump. This is what the problem in the pump, and we'll come to know these are the what is cavitation and why it is caused. Why it is caused means high impeller speed. When the impeller speed is high, because of that the cavitation take place, and small diameter of the suction pipe, and an inlet of the impeller. Small, if the diameter is small, so because of that it will take the too high specific head, the specific speed. Sorry, too high specific speed. Because of that, it will be causes and high temperature of flowing fluid. When the temperature increases, that is also called, and that is I said net positive suction head. Net positive suction head is required is greater than or equal to available. So these are the causes of this cavitation. And pump, if the cavitation what it will do damage, what means the damage because of this cavitation, what damage is on the pump, the failure of pump housing, that is outer casing is that will get failure, or destruction of impeller get damaged because of that bubbles or expanding, or bubbles or getting open at the blades, and excessive vibration because of the bubbles and movements and all the vibration take place. This leads to damage in the sealing or bearing will be get damaged, or breakdown take place, and higher than necessary power when the power consumption requires more because of this, and decreasing flow and pressure because of this cavitation, the water bubbles, the whatever the water discharges, it will reduces and all. That is what the drawbacks of this. And so to avoid that, what we have to do? So to avoid that, we have to maintain the low velocity of liquid in suction pipe. To maintain low velocity means we need to increase the diameter of the suction pipe than the delivery pipe. That means the suction pipe should be bigger than the delivery pipe. By maintaining that, we can avoid this. keeping low temperature of flowing liquid like this we can get, and using suction pipe. We should be it should not be, it should be free from sharp bends, and if the sharp bends are there means there is a pressure difference take place. So like this, by maintaining the uniform bend and all, avoiding the sharp bend, we can control the cavitation. This is what the cavitation, and what are the problems and how it will occur, and what damages on the pump, and how to minimize. And next one is priming. This priming is nothing but, I said in the working principle now, in the working principle, if the water is not present in the casing, impeller and suction pipe, there is not much negative pressure is created at the impeller. If the negative pressure is created, then the water will be sucked from the sump to the impeller, and the water will discharge take place at the delivery pipe. If there is no water, there is much suction pressure will not be created. So that is why this priming is needed. Priming is nothing but filling the water to the casing, impeller or in the suction pipe. So filling the water is known as filling the water to casing, impeller and suction pipe. That is called as priming. Why priming is needed means, if there is no water, when the impeller rotates, it will not create much negative pressure to suck the water from the sump to impeller in that means eye of the impeller. So that is why if the water is present, then what happens? The negative pressure is created, then continuous flow of water takes place from the sump to that is a motor, that is input, that is the eye of the impeller. So this is why the priming is needed. Priming can be done in a three, but different methods are there. The one is manually priming. We can put the water manually. By using vacuum pump, we can priming can be done, and by using jet pump, we can do the priming, or by using this separators. By using these three arrangements, we can do the priming. This is what the all about the construction and the first. This will finish the chapter of pumps. Okay, got it. Today we discussed what is the things. First we discussed the classification we finished, and next we discussed the centrifugal pump, and then we centrifugal working of centrifugal pumps and all we discussed, and next we discussed the reciprocating pumps working and all we finished, and what is cavitation we finished, and what are the priming is we finished. This is about the concept of hydraulic pumps. Understood?